Hello, hello, hello. Good morning, everyone. Thank you for coming here on a beautiful rain-soaked morning. Instead of going on a walk or a run, you decide to come here. Okay, and online audience also, a very warm welcome to you, and thanks for joining. We have Professor Yogesh Simhan, who is the convener of IBM-IISc Hybrid Cloud Lab. He'll be giving a note of welcome, and then we'll start the proceedings.
Great. Thanks a lot. So good morning all, and more than anything, thanks for sticking around after your final exams are over and not being back home. So it's a big thing. I can trace back at least my close interaction with IBM Research to maybe about 7-8 years back when we had this ACM India Winter School on hybrid clouds, where me and Amit, we put together an agenda. We had many speakers from IRL come in and several from IISc. And from then, a couple of years later, we had this idea about having a joint program around hybrid cloud and AI, and the conversation started in about 4 years back, right? We actually established a joint research collaboration between IBM Research and IISc called the IBM-IISc Hybrid Cloud Lab, right? And we finished 3 years. We are in our 4th year right now of this very successful collaboration. And one of the very interesting things that happened as part of this is that it's an open research collaboration. And that's saying a big thing coming from IBM, which has the largest number of patents in the world, right? So for them to actually have an engagement with the university where everything that we do together is put in the public domain as publications, as papers, open source code, open data sets, and so on, is really a big thing. And that shows the mutual trust that we have instead of being able to come together as researchers to actually do something big jointly, like looking at industry-focused programs, looking at the state of art in terms of research. And we have, in the last few years, managed to span a spectrum of topics, starting from how do you optimize data centers using AI, how do you actually do things across multiple clouds through functions as a service workflows, how do you optimize AI workloads specifically, right? With the intent of balancing power and sort of performance and accuracy and so on, right? And also even work in terms of reliability and such of cloud workloads, right? And more recently, we have even forayed into quantum computing, where IBM is obviously a leader. And we are happy to be working on the hybrid cloud from a platform perspective, right? So, and this today, an event that's been put together in a very short notice, and we have some great speakers today, is and again another testament to our ongoing engagement. We have already a series of talks. You might have seen the IBM-IISc Hybrid Cloud series, right? We have about 10, 15 talks a year from various experts from outside IISc in India. So this today is something that's more inward focused so that we get a chance to hear from IBM researchers in terms of some of the top cutting edge research that's going on. And can give you some nice ideas for new research problems. Maybe you want to sort of join one of these projects, work as part of that. Maybe you see internship opportunities coming up at IBM or even sort of placement opportunities. So make use of this. We'll have about 5 or 6 IBM researchers here. Do talk to them, network, and let's see how we can strengthen this partnership for them, right? And over to you. Thank you.
Thank you, Professor Yogesh. Yeah, so I think everyone is excited about generative AI and right from the the math and statistics and algebra behind it, like what makes the black magic possible in some sense, to the application oriented, just writing prompts and chat and generating images, which you may be familiar with. But between this spectrum and beyond that, there is a lot of engineering that happens, and a lot of optimization and engineering design. And who better than IBM folks who are working on these, building these systems, working with clients to develop applications and models around their platforms and other systems, and contributing to open source projects. So that's why we are lucky to have IBM researchers from IBM Research Bangalore coming to us and sharing their perspectives and thoughts about it. And hopefully, by the end of this day, you will be able to put the things in perspective, put the pieces of the jigsaw. You may already be familiar with the software part of it or the applications part of it, but these missing pieces that connects everything together and make things happen at scale and in production is what I hope you will be able to gather from the talks today. And of course, one big shout out to the IBM folks who agreed to come at a short notice. And second is the sponsors, Cisco Corporate Social Responsibility, who are sponsoring our Center for Network Intelligence. So they have been supporting all these activities. In fact, let me go to the web page to show you the outreach that you can take a look at. So we host a whole lot of activities around. We have some online courses. Weekly, we have seminars that happen on different topics. We host a hackathon. In fact, we are hoping to launch a hackathon around the theme of AI in partnership with IBM and Hybrid Cloud Lab. And we also host a summer school. We send our newsletters, and this is the workshop that you're attending. So Yeah, so Center for Network Intelligence, I'll talk about it later, maybe during the break. And I think let's get started with the technical sessions. So the first session is around the introduction, and the speakers are Pratiti and Pratibha. So Pratibha Mogi is a senior research manager in IBM Research at Bangalore. She is currently leading a research department focusing on efforts to build differentiations in hybrid cloud with AI. She is also investigating GenAI applications for IT automation and also building observability capabilities in full stack AI. She has a PhD from OGA School of Engineering, OHSU, and master's degree from IIT Kanpur. She's worked in industry labs for about 24 years. She has 10 plus key patents and several publications in signal processing, speech and language technologies, and automation and observability. Pratiti Mohapatra, who's also going to conduct this session, is a senior research engineer and manager at IBM Research Lab India, working in AI in operations, observability, and cognitive support. Her current focus is on bringing AI solutions to IT operations, providing more insights with reactive, predictive, and proactive capabilities. She has received numerous awards, including Research Division Awards and Outstanding Technical Achievement Awards in cognitive support and AI ops. So over to you, Pratibha and Pratiti.
Maybe I'm going to start with this. Batch. Yeah, I don't have a pocket. Am I audible, guys? I think it's a small room, so I will be loud enough to be more clear. All right, so I think it's a great pleasure. I am so happy to be here every time Yogesh and others give me opportunity to be in IISc. I have a long relationship. Actually, when I was about to pursue my PhD, I spent almost 1 year here being a researcher. So it's always good to see the crowd from IISc. So we have a very interesting session. As you know that generative AI, generative computing, you see every single day one or the other article, and things have evolved since the chat GPT was launched 2 years ago. It's almost like analogies, speech language technology. Like when I started doing my PhD in speech recognition area back in 1998 onwards, the Siri came in between and the whole thing changed, Google Voice and everything, right? And then technology became very mature, and now you guys see that everywhere using the speech and language technology. Similarly, the generative AI point of view, I think a lot of happening, and industry always look around for productivity, cost efficiency, doing more with less resources. And I think it's very apt to say that generative AI brings a lot of such potential and bucket of technologies which you can use to bring lot more automation, just like, bringing these human proxies to do a certain workflow, build some applications, bring more natural language interaction, all of that, right? And I guess all of you must be looking at what is happening around this area. So in this particular session, I'll try to give you some motivation and context, and then my colleague will take you to a little bit use case level dive, just to understand how these technologies are getting shaped up, getting employed, getting embedded into solution, especially in the enterprise domain. Okay, So I started this picture. It has come from our very senior leader, David Cox, and I just fell in love with this picture. So you know that the imperative computing is there for long. Everyone, we are as a coder, right? We know what is the input space. We know exactly how to code a set of steps to generate certain set of output. So we know what we want system to do and how that system should operate on the input space. And all the programming paradigm, the software development industry just banged on the imperative computing side, right? Moving to inductive computing, which is all about machine learning, learning from data, how to code certain things, which you otherwise cannot code using a functional programming. You see a big suite of modeling paradigms which comes into picture and which allows you to tell system what to do given an input and context, right? Now the world has moved beyond inductive computing, and now you have yet another a term which is getting more discussed in the scientific communities, that of generative computing, right? Given the input, you're telling system what to do in a simple natural language expression. And now the science is to tell how to tell the system to generate an expected outcome is all about generative computing. So the big science on prompt engineering, right? Prompt construct, that different kind of agentic framework bringing into picture, that is also kind of a programming. It's a way to program, like you program in Java, write your classes, functionality construct. Similarly, now it also has become a paradigm of programming agentic application using natural language expressions with the help from the system prompt, right? Prompt engineering. So the world has now gone to generative computing, and you will hear about it more and more as you go in at least couple of years from now, because we know that NVIDIA is making the maximum money, right? Banking on the generative AI. But using generative AI in automating the whole world, still enterprises are actually betting big time just to see what kind of efficiencies they can bring into not only the development cycles, but also automating customer query support system and whatnot. I mean, we will take you through those applications. So just as a context, I just want to give you this as a picture, how the things have evolved over last maybe 7-8 decades. You had expert system where rules, human rules, played a role of automating some processes, right? It moved to machine learning, plethora of machine learning algorithms, different paradigms of learning. It took place. Data science was coined maybe 6-7 years ago, right? Then now it's all about deep learning, because you had a lot of hardware resources which came into picture thanks to NVIDIA GPUs. We could do much more deeper network training using backpropagation. And as you might know that backpropagation was actually invented in 1960s. It's just a gradient estimation algorithm, and somebody just put as a part of the neural network training, and it became like boom, right? And then people started playing, became more inventive to add more and more layers. And at some point of time, GPU started to accelerate this whole play, right, for all of us. Now, from there, it is something called foundation models. Now, just by architecture, it's not good enough. You need lots of data for it to absorb, right? Because your modeling complexity is now increasing, and it has more degree of freedom to model the whole large distribution, which is embedded in this variety of data space, right? So now there's something called foundation models, which are like a sponge. It's my own analogy. So it's like a sponge. It's actually getting all the publicly available data, trillions of tokens, your symbols, space, right? Code, images, and then absorbing that distribution in its own manifold and able to providing you this conversing ability, right? It's able to answer your questions the way you want to look at, right? So just another picture here. So we have supervised learning, you know already about that, right? You have input space, you have target space, and you want to regress your X to Y. So a lot of suite of methodologies in this place. A lot of computer vision problems fall under this domain. You see a lot of things being put on mobile, your smart gallery, smart camera, all those kind of suite of things, right? Then you have unsupervised learning, which is like a plethora of clustering algorithms, just without relying on labels. You want your system to learn about how the data is distributed and probably use it for some kind of inference, right? Representations. Then here comes the self-supervised, semi-supervised learning methodologies, which really were the game changer. Because here our dependency on the label, quality labels, drastically reduced, right? The input itself tell you what is the label against which you want to regress your model. And that changed the whole game. And then people started to utilize all the public data, public knowledge. You can also imagine like billions of minds expressing through internet, expressing through social media, all sort of knowledge, communicating with each other, right? Now, in that symbol space, you have the self-supervised, semi-supervised learning algorithms at your disposal so that you can learn the user behavior. You can draw insights from data and then utilize it later for your own purpose. So that is the basically genesis of generative AI. Then reinforcement learning. This is still evolving, I would say. It's on the go learning and basically adapting your decision boundaries based on this concept of reward and penalty, right? Because the distribution can change over time, user behavior can change. So one-time training, it gets away from that paradigm, right? Going to next. So this is how we see it. I think I already stated, you know, the huge amount of public data, and you see ChatGPT, Mistral, you have Llama series of model, and then our own IBM Granite suite of models. So huge amount of work is happening in the scientific community, and enterprise started to seriously look at how do I use my enterprise data to customize these model, fine tune my model for my own purpose, which can bring value to my client. Okay, so this is where the industry is going. And also, there's very interesting, some of the papers, I was talking to Pratiti a few days ago, that in the deep science domain also, people are trying to understand how Gen AI can be applied. So we also have discovery science, impact science teams within IBM, looking at very, very deep problems coming from genomic data, NASA, geostationary, spatial data, all of that. So we are becoming more innovative just to see how we can use these big complex model which can learn about a vast amount of data and knowledge that is present to you and build some intelligent applications on top of it. Okay. But from industry point of view, the primary questions are, how do I build trustworthy model? Because even if I build my foundation model and if it breaches somebody's privacy, right, then it's a big problem. So trustworthy AI, you could also read about it. It's a big topic by itself, right? That is one. How do you fine tune it to your purpose? So my colleague Mehant and Nabha would talk about it, like what are the techniques we have right now, which allows you to customize a base foundational model to serve a purpose that you want to build your models on, right? And of course, deployment scalability is also important, because when you take and have this GenAI capability launched somewhere, you need to support millions of queries. So how do I scale? Then there's some bit of hybrid cloud optimization, distributed computing optimizations comes into picture, right? So just looking at the GenAI offered functionality, as simple as content generation based on some of the knowledge base, right? So this is one of the functionality where a lot of research is happening to improve year on year. Summarization and explanation, right? Then you have predictive and forecasting capability that also is very, very important, because not every single data is actually text. It is IoT data, it is medical data, lot of things which requires time series view to look at how things evolve over time. So you want to do a very good predictive analytics, you want to build forecasting capability into your system. So this is one kind of functionality, right? Then you also have very lately, I think maybe last 2 years, code generation capability, treating code as a language. This is a new paradigm, right? So this also it has become extremely important and focus area for many enterprises because developer productivity is a key, right? You have some bit of templatization happening. Let's say you are developing a Flask API, right? You have a certain pattern. You look at Google, you look Geeks for Geeks, a lot of such website. This kind of a templatization you have. So can we use that to learn through the GenAI and then use it as an like information retrieval tool for you? It completes the code for you. It gives you suggestion. It explains if you don't understand that piece of code. It fixes bugs for you, right? So all those are kind of use case scenario. Then we have lot of thinking going on. How do I create agentic workflows, which used to be called chatbots, but it's becoming more complex in nature, multi-agent. So my colleague Dipti will be talking about that. So the another thing is the agentic workflow agents. How do you build that up using the whole GenAI stack, right? Then of course, automation in general, everywhere. So digital transformation, digital acceleration, everything through automation, right? As you know. So then bringing these interplay of human proxies, so-called agents, right? That has become like a talk of the town. A lot of work is happening. You must have heard Andrew Ng talking about different design pattern in the agentic workflow. Some of that Dipti will also be covering. So that is also a research focus area, okay? So I think I'm pretty much there. Yeah, and industry use case scenarios, all market segment, be it retail, finance, right? Any kind of R&D units, like you have sales assistant, anywhere where human is involved and you see workflow can be automated, you have a play of GenAI, okay? And life sciences, drug discovery, plethora of use case scenarios which are upcoming. And I think it's a very exciting place, and I'll hand it over to now Pratiti, who go yet another level down and give us more feel of what kind of use case scenarios, what kind of functionalities that IBM is developing and also the world is focusing on. So over to you, Pratiti. Thank you. So we can take questions later. You guys can interrupt.
Okay, so continuing on where Pratibha left off, right? So a new kind of framework is evolving and evolving very, very fast, which is agentic workflows. So now the power of agent is you sit, there is like a master kind of a planner. It basically consists of 4 steps. Reasoning, the model's power of reasoning, model's power of using tools, model's power of planning, and multi-agent. So for example, this is a sales example, but let me give an example of a medical doctor, right? So a patient comes to him, he has to do a lot of tests. So all these tests results are in some tool, right? So now what you do is you build an agent which knows the know-how of this tool. So he knows the input and output of this tool. So you give all of that information to the agent. Now the doctor or somebody in the medical community comes and says, can you actually generate a nice detailed report in a user understandable language for me to present to the patient? So what the agent will start doing now is it will start kind of planning. Oh, okay, this is, it start to understand what the query is, what the ask is. Depending on the ask, it might plan some steps. I need to gather this report for this customer, for this time range, and generate some nice, friendly way for him to understand. So collating all these different, it's a very simple example, but it gives the power of what agentic workflows can do with you. Now we get reports, physical reports, we have to actually manually look, oh, my BP is really bad, right? But can I connect this BP to something else? So there is a lot of, innovation going there, where the models can also critique themselves. So till now we were, it was like, okay, some human comes in and tells you this is wrong. But now we're also giving models the power to critique and reflect and observe. So let's say they have recommended something or they've generated a summary. They can ask a human who can be a proxy agent, or they can ask another model to say, does it look good to you, right? So all of this power is now coming in, and a big play in agentic workflows. You will see a lot of examples in code, which Deepti will share in his sessions. Okay, so we were also looking at, how GenAI is evolving in the science domain. And this is very interesting. So these are, snapshots from papers that we pulled out from. As Pratibha was mentioning, code is now being mapped to language, right? As we are talking, can we also map the way we code as language? So let's say code is now a language, right? You start saying, okay, print hello world. When you are starting talking, you are saying to the other person, print hello world, right? So that is how they started mapping code to language. Similarly, in the science domain, it's very interesting. I don't understand science, this is not fine, but maybe the scientists who are present here will understand. But if you see here, they're mapping amino acids to alphabets, right? Then it goes to the protein level, which makes kind of tries to structure the word. So J in bicycle ride. Then they're trying to give a semantic meaning to something called function, right? So Jane rides her bicycle. Now it is forming a meaning. And then, you can make paragraphs. Like in language, you can have sentences, you can have paragraphs, you can have documents, you can have chapters. So this whole structure, the science community is also now trying to map to language to just see how they can adapt GenAI technologies to science. And the challenges still remain. The model needs to know the domain language, right? The model needs to understand the heterogeneity of the data modalities that even science is captured. So there are still challenges, but I think people, and these are very new papers, maybe late last year it started. And then you can see here at the next, let me go here. Here, right? So this is actually a paper in Argonne that they did, that they were doing some kind of gene which is generating some sequences, and then they had some, so a lot of sequences got generated. So they wanted to filter it out in some way so that the sample is kind of, in a form that can be used. And then it went to, so this is a very nice example where they are plugging theory and experiment. So the whole reinforcement learning is actually coming from experiments being performed back to the model, right? So this is one example that we could find. This is another example, Europe's paper, which is in physics domain, I think. So a lot of PD tasks they had, and they had all of this data, and they had different set of PD tasks. So they built one base model, and then they fine-tuned it for different PD tasks. Okay. But also in IBM, we have a lot of emphasis on science. So this work is a collaboration with IBM Research and NASA, where you have a lot of geospatial representations. They can be in terms of time series, they can be in terms of excels, images, etc. And you want to kind of do different kind of tasks, right? Detecting burn scares, detecting floods, land use, land cover mapping, which land is more agricultural, which land is more industrial. You can do this mapping, you can do crop classification. And interestingly, these models, the top one is actually a binary model. So it will say it's either one or not. This land is either a burned land or not a burned land. And this is a multi-class model. So this is also a power of the whole GenAI spectrum, where depending on your tasks, you can tune it that way. This is another one we have, where I think it's, again, please read it out, it's not my domain. But this is also work from IBM in chemistry, where they have these large chemical data sets, and they go through the whole I think this is a very popular data set of smiles, which has a lot of chemical language representation. So they've used that data set to do these tasks: property prediction, molecular similarity, attention visualization. And recently, Nobel Prize for Physics, we did see John Jumper AlphaFold coming out from Google to protein folding, right? So that's also based on transformer models. But then there are other expansions to it. What is a path with protein folding, right? So these are some things that, at least in the science community, is happening a lot. Okay. We are from IBM. So I also wanted to give a flavor of how we are using GenAI with a task called IT automation. And hopefully, you will be able to map the data modalities, the data complexity to your projects, okay? With this example. So let's say, I'm hoping most of your students here, you want to build an application to sell books and bicycles, right? And you have this application, you're hosting it on IBM, on cloud, right? So this is how maybe your application looks. So you can have services like front-end service where the user comes in, logs in, registers. You can have a service where ordering is taking place. You can have a service where payment is happening. So it can be as simple, it's not as simple, but okay, relatively simple, or it can, at the enterprise level, it can be a lot complex also, right? So going with this example, what you want to do, you want to keep your application running all the time, right? So you kind of employ a monitoring, you go to some external company and say, can you see, or a cloud kind of provider and say, can you help me manage this application? I don't want the website to go down, right? Every time a user is going into my website, he should finish his order, get the receipt back, right? So somebody is monitoring. And what that monitoring tools do is they kind of get this kind of data. So for every microservice, when I say microservice, think of it as a function or a module in your code. They are taking, okay, memory utilization is fine, utilization is fine, right? So they're constantly monitoring data. So this is a very structured time series data, right? What is this? This is logs. So when you code, you will have some kind of logging principle. This is the ideal way of coding, especially in the enterprise level. So if something fails, logging logs actually help us to debug. So think of logs as your print statements that you're storing. Right? So the monitoring tools also give continuous kind of feed of logs coming out when your application is getting used. If you see this data, this is not grammatically correct English. It's very unstructured. It can be semi-structured. It can be structured. And then you have traces, which means I, as a user, went to an application, I registered, I looked at the various products, I liked this bicycle, and I went and did this payment. So at runtime, how are users using your application? That information also monitoring tools store, right? So at runtime, you are getting all of these kind of data sources at scale. So you have to process all of this at scale at runtime very fast. Okay? So that's the challenge in IT domain. So again, I'll not go through this. Currently, what they're called reliability engineers. Every enterprise have reliability engineers. The task is humongous. You have to look through all this data, all of these panels are up there. If a failure happens, how do they get your website up and running ASAP so that you don't lose money? So all of this are the challenges that we face. Heterogeneity, dynamicity. Because it's hosted in cloud, things can be rapidly changing dynamically. Okay, so I'll move fast. So what we are trying to do is some of these tasks, right? So we want to kind of, there might be, let's say a fault has happened, right? Somebody is not able to do an online payment on your website. So it's called an incident. So fault has happened, incident has happened. But since the monitoring tools are constantly monitoring, incidents will come pinging at you, okay? Not working, not working, not working, not working. So it becomes a headache for any human to actually sit and always get this pager alerts. So we want to kind of group these incidents, summarize these incidents, find the root cause, why it failed, and try to give solution through recommendations or through code and stuff. So I showed so this is how we are dealing with, right? So this is topology, which is graph data. This is metrics, which is structured time series data. These are logs, which can be structured, semi-structured, unstructured, English, non-English data. And these are traces, which are again time series, but in a graphical way, right? So I think spatio-temporal representation is key here. But now if you come here, we also have documents. We also have tickets. So we also have manuals. We have Slack conversations, right? So I hope this is giving you kind of the complexity of the data that we have to deal with. Coming from full-on text, language, to signals, graphs, time series, etc. Right? And this topology is basically how you've built your application, right? So in your code, when you do that, when you used to do this object-oriented programming, you had this nice, way of formulating or designing your code architecture. So that is what topology is. Okay, so we will have a session where we will give you a flavor of IBM Granite models to kind of tackle some of these tasks that I've mentioned, these challenges. So this is the IBM Granite model session where we cover code, language, and time series, right? So if you have time series data, you have code or language or a mix of everything like we have here, then how can you use IBM Granite model? So we have a session on that. We also have a session on fine-tuning and inferencing. So as I said, we have all of this data coming here. We have a base model. So when I saw all of this data, all IT domain data, like my domain is now IT, right? My domain is not science. So I've taken the public model and I'm now doing pre-training on my data. So now my model knows the language of my domain, but then I have very specific tasks that I want to do, right? So I want to do script generation. I want to do log analytics, incident summarization, and that there are different variations of fine-tuning you can do that Nabha and Mehant will cover. And then how do you inference? Once your model is ready, how do you do inferencing on it? That is something Felix will cover today. Okay, but another thing is data quality, right? So once you take a public model, the first question you want to ask is, how is this base model performing in my task? That's the first thing you will do, right? You go to ChatGPT, you write a question, generate a Python code or a Fortran code or whatever code, and then you just want to see, okay, is it doing the right thing, right? So maybe not, right? And then you have to go back to your basic and say, okay, I really need this model to understand what I want to do. So to do that, first step you have to do is data curation, data preparation, data quality. Very, very important stage to start anything, not from scratch exactly, but like scratch, right? So we have Shailja talking about this session, which is the next session. Okay, so just to end with the agentic workflow, how we are using in the use case that I mentioned. So currently, what I mentioned in our use case of selling bicycles and books was a very fixed work, right? But it can be dynamic. And how can it be dynamic? Let's say you said, okay, this, because it's hosted in cloud, maybe a pod is faulty, right? So the cloud engineers will understand this. Let's say a pod is faulty and you want to kind of delete that pod. But by doing that, something else went wrong, right? So the system is very, very dynamic in nature. And that is the problem with the whole things. Yeah, we are going very digital, we are modernizing ourselves, but these dynamic conditions start happening. So how does agentic help here? Multiple ways. We tell the agent of all the tools that we have. We say, oh, okay, we have something to get metrics. We have a tool to get the topology. We have a tool to get documents. You can go on the web and get these documents. And then multi-agent. This is the concept of multi-agent, because every human is skilled in one particular domain the best, right? He may be multi-skilled, but at least a network SRE will know the network domain the best. So this is the concept of multi-agent, where you're trying to bring in skills from different domains to solve one big problem when a failure is happening. Okay? So more detail on this, Deepthi will cover. And so that's the session that we have for this. And just to finish off, And you will get more, more such research opportunities with the follow-up sessions, and every speaker will give you a flavor of, what are the challenges and what are the opportunities. I think the big thing now, at least in the enterprise level, as Pratibha also mentioned, trust, interpretability, explainability, transparency, right? And specifically, if it's a situation where you don't want to trust the AI model directly, medical science, right? So you want that kind of transparency, explainability. The model should tell you why it came to that decision. So those are very, very important. You want to protect the data of your clients, especially banking data, right? You don't want to bring out all the data in row. So how do you secure your data? So that's a big challenge, and it's a very important work. Domain specific, as I said, I gave an example of IT. You move to sciences, to physics, it's a different domain, it's a different language that the model needs to learn. So that's another challenge. Multimodal foundation model, I gave you a flavor. You have different data modalities. How do you bring all the data modalities into one model, or is it separate models and you converge later or converge earlier? All of these are very, very interesting research problems. Scaling and deploying, you cannot do it on your Mac, it won't work. Even if you go out, there is a cost involved to use LLMs, you have to optimize. So how do you scale and deploy at that level? And this is something, at least in IT automation, we have seen a lot, because we have so much of data across modalities. There is a real kind of, ask, not an ask, it's actually important that you kind of do this causal analysis across these modalities, right? So if I have metrics and logs, and if you're working it on silos, it may not help you to understand where the fault is or mitigate that fault. So how do you bring causal inferencing, reasoning, and planning capabilities to models? And that's a big thing that we're seeing, especially in IT domain. So next session, in a nutshell, as I said, data preparation, data quality is very important. So we'll touch upon that in the next session. Now, let's say you have got the whole gamut of data in your world, in your domain. You also have data for your tasks that you want to fine-tune your data on. That will be our training fine-tuning models the next session. How to serve models, inferencing. And then finally, we'll end with the agentic workflow session. Thank you. That was my last slide. Yes. Any questions for Pratibha and me? We are around, so you can always catch us.
Who have interactive questions? I would love to see any questions coming out of such a good conversation around it, right? So believe us, like we are all learning along with you. So it's good to have some more interaction during the session. Any question, guys? Yeah. Yeah, this all slides will be available. So basically what it takes to build trustworthy models, right? What kind of data processing mechanisms, algorithms you want to have, how you want to design a system so that you trust the data on the basis of which the GenAI model is trained. Even if you pick up a public model, how do you ensure that you wall guarded its output, right? That could be one specific problem statement, but of course it goes beyond that, right? Transparency, that is also very important. So somebody to trust you with your model, you have to tell them exactly how the model was trained. You need to maintain transparency from a whole AI pipeline point of view, right? Little bit of engineering, maybe more scientific problems around that, right? Then, of course, the evaluation metrics, because if you see the evaluation metrics, they're all driven by language. We have a lot of metrics evaluation framework, but we are moving beyond language. So what kind of evaluation metrics one can have, right? Let's say for code generation, your custom genomic data related evaluation metrics. So what kind of treatment you want to apply? All of that is like subject to a lot of scientific studies and research, right? And as Pratiti said, multimodal, because we are all multimodal in nature. So still, this field is very fast evolving. You have an intermix of language, the text, and the image. You may have many more other modalities, especially from manufacturing domain, where different kind of IoT is generating that data for you, right? So another field of study, maybe new architectures we need to think about. What is beyond GAN, generative adversarial network, right? So that is another one. Then scaling deployment. So power, performance trade-off, lot of optimizations, right? What kind of algorithmic treatment you need there, required there. And of course, the models by themselves do not have reasoning capability. So this is again a very, very deep research problem, so to speak. So this is another area where if you have interest, you can start reading and see what can be done better, right? So this is just, I gave a recap of the research opportunities. Please look into literature. I think some of the references Pratiti already have provided, and do more fine readings, right? Thank you. So maybe next session, yeah. Yeah. Yes.
Hi, this is Amit. So one question, it is not related to a technical content, but it's about like how the workforce requirement changed after LLM and all those things, or the skill sets that you're expecting from the people. Because I don't know if they are still consistent with the what we have seen 10 years back or something after LLM has been there. So
I think there's no surprises. As the technology spectrum change, there's like, we as a human, being the supreme species, we adopted, right? Anything which has very high potential of templatization, you may not do it manually. Everything can be automated. Probably you'll spend that time for doing something else, which it still requires you to build a template on. So this is the evolution story, right? I mean, anything which can be automated, you will ask machine and system to do, but you will be building that system. So skill will be more on creating these higher level construct, abstract layer, right? And actually, so I'm probably talking from the technology development point of view. If you ask me as a whole humanity, I don't have any answers for that, right? But in the technology domain, it will be building those higher level of constructs to bring more efficiency. And of course, from a business side, people will put more money on where you show the potential of efficiency, bringing productivity, cost efficiency. These will be the business level metrics, right? So that is what my answer to you. Thank you. Yeah. Anything else? Yeah. Oh, okay. Yeah. There's some online questions he's saying. We can take it in the end when we wrap up. So you can just consolidate that and you can tell them to hold. Maybe you just do the bookkeeping of those questions. Okay. All right. So I think over to you, Preetham. Thank you.
Thanks, Pratibha and Pratiti, for setting the tone for the rest of the day. Sorry, we are not taking more questions right now because of time constraints. So we'll start with the next session and probably we'll try to take the questions towards the end of the day. Next speakers are Mehan Kamakoti and Padmadaba. Sorry, next session is by Shailaja Thakur and Hima Patel. And Shailja is a research scientist at IBM Research, and she holds a PhD from University of Waterloo, Canada, and completed a postdoc at NYU. Shailja's research focuses on developing methodologies for preparing high quality code data sets essential for building foundational code models. She has published in NeurIPS, DATE, DAC, ICC-AD, and many more top level conferences and journals. And she is actively involved in building open source communications such as communities such as BigCode. So over to you, Shailja.
Thank you so much for the introduction. So let's get started. I will, I'll get ahead quickly because we have a lot to cover and very less time. So I'm talking today about how can we build successful LLM applications using the power of high quality data. I'm audible here. Perfect. Okay. So we will be talking about what is crucial, which is high quality data, and how can we prepare that data, and what are the challenges. So this is what we will cover in this session. So as we go about, in part one, I am covering, as I said, I'll talk about the challenges, why is it important that we have to develop high quality data, and what are the state-of-the-art methods that the community in general is using to prepare that data. I will also talk about some of the method that we have come up with, in particular, within our team at IBM, and that will be followed by a demo that literally shows how can we go about developing or preparing a data that we can take towards fine-tuning or training our language models. Okay, so let's get started. And I will start with a very, very small story. So we all are having some persona, right? We are either a data scientist or a researcher or a developer. We take on the hat, like we wear a hat at some point in time when we have to develop some project, right? So even when you're doing some sort of you're a part of a competition or you have to develop some project, you have a problem, but you have a whole mound of complex intermediate tasks that you will have to do, right? So anyone who has to develop a project, they will have those tasks and they will have a time, they will be literally bounded by time. So, right? So they will have to think about everything. So what are the skills they require? What are the techniques they require? What are the tools they require? How to put it all together within the timeline, because the time is running out. So that's the key. So let's pick up, this is just a problem, literally saying if you have to solve a problem where you're asked to develop a language model that is proficient in a particular programming language, which is, say, Python, or say something that we don't use these days so often, which is called COBOL, right? So you have to make sure that your language model is having an expertise in that particular language. How will you go about it, right? You will pick up something that already exists, right, to see if it has any capability in that language. So does it have any capability out of the box? It is possible that it may not have, because generally, if you have to pick a model from the public domain and check for a specific thing, it may not be very good at it, right? So what will you do? You will probably just make sure that you will take some data and which is specific towards COBOL, right? You will pick some of the source code from, say, some open source GitHub repository or some source that you have access to. And you will prepare your data. You will fine tune or train your model, right? Now you will check whether your model has achieved the expertise in generating COBOL specific tasks or not. And if it has not, then what would you do? You would probably just keep on repeating the cycle until you would have made the model expert or a master in generating COBOL. So what happens here is it goes through stages, right? So you will have data, you will prepare your data, meaning you will have done some sort of a cleaning on top of the data. Then you have taken some model, right? It can be either a model that is not trained at all, or it has been maybe trained before, and now you take it and you train on top of it with all the COBOL language data set that you would have. Now, later you would go ahead and you would have some test set, and you would keep on testing if your model is good at generating COBOL or not. You will keep on asking it questions. Can you implement some task in COBOL, blah, blah, blah. And you will keep on doing this until your model has attained that mastery or not. What happens here is you're going in iterations, keep on doing these tasks multiple times until you have an expert language model. So this is an iterative and a time-consuming task. Right? So that's one of the major problems. And another thing, this is just a study. It was interesting, so we picked it up, which shows, it is coming from Gartner, and it says that there was a study that was done which shows that there were two teams and they were asked questions, and 80% of the team members said that data preparation is the top priority in the task, the AI related tasks they do. And second, they also said that 30% of them said that handling the volume and the complexity within those data is another and key issue that they deal with before they are developing any AI related algorithm, let alone language models. So this is, and that quotation is literally saying that robust data preparation method as a practice to build a foundational model that is successful at doing some tasks, right? So having said that, what are the, so putting this data preparation stages in context with the LLM development lifecycle, what are the various stages or the intermediate stages that you will have to go through? So if you can think of, look at it like, for instance, going from data ingestion, which is literally saying that you will take data from various sources. Pratiti and Pratibha also mentioned there are different modalities of data that you will have. They will be coming in here. Now what you do some sort of data standardization on top, which I'm guessing you all would be knowing. You would literally just want it to be within certain range so that you can handle it computationally well. Next, what you would do is, these are very specific stages that you will have to apply when you have text or code or sequence related data set per se. So here data duplication is one of the stages. We will talk about it in detail when I go further, but it is literally just removing repetitions that you see in the data, followed by various other quality filtering stages that also I will cover. Then there are various obscene and those profane kind of words that you may see in your data set as well, which you would want to remove so that your model is not learning those bad words. Followed by, yes, license filtering. A lot of the code snippets or data that you see on the internet, they are copyrighted in nature, meaning they will have some license associated with them. So you would also want to make sure that you do not make your model train on those licensed data, because it doesn't know that it will have to retain those licenses when it is emitting those similar type of data later. It skips those, and that's a violation. So you do not want to do that. So these are all the data preparation stages that you will have. Followed by this, what you would do is you would tokenize it, literally having a numerical representation before passing it to the model training stages, right? So we will only talk about these stages. Rest, our other team members will talk about. So let's go ahead. Yeah, so this is just in a nutshell talking about all of the general challenges that we have with the data set that we have to use with the language model, which is that you have unforeseen hurdles, meaning when you are looking at web scrapes of the data set, there can be unknown challenges which you may not be familiar with. Then there can be the requirement for verification of those data sets, right? So literally having a review of those data sets. Can you do that on like terabytes and gigabytes scale? No, you cannot. So that is another challenge. Then third thing is you will have data from different modalities. So you will also need to make sure that your data processing takes care of those long tail problems where the data from various different kinds of modalities can also enter in. And you need to have the processing stages available that works for those specific modalities as well. Then there are not tools already available that can automatically scale and simplify your complex data processing stages. And then all in all, finally, we need to automate these no code processing stages, because these are super complex and we need to pack them together so they are somehow automated, and there is a sort of a framework that we can take in and just
work out of the box for us. All right, which is why we came up with this data processing tool, which we are calling Data Prep Kit. It is open source, publicly hosted on the GitHub, and it's an open source collaborative project. So we are also welcoming collaboration and contribution from the developers, from the open source community, and whoever is interested. So please do go and have a look on our data prep kit. I will talk about the various specific modules that we have developed. So these pieces that we have, which helps us prepare the data coming from different modalities. Currently, it works for natural language and code. But because it is also open source, there is also the scope for contribution to what already exists, because this is not the exhaustive list of processing that we can do. It keeps on growing and it keeps on expanding. So this is also a scope for all of you to sort of contribute to this open source project. Okay. Let's now start talking about some of those recipes that I showed in the previous slide. So why do we need those, and what are specifically those data preparation techniques? I will start with why do we really need those? Why is it challenging to have duplicates? I mean, even if our data set has duplicates, why does it really hurt the model? Does it hurt? Does it benefit? What really is the impact on the language model? Think about a language model. Language models are literally gigantic in nature, at least in their current state. They literally have millions and billions of parameters. So how is it impacting our model? One of the major challenges with these language models is that they memorize the data rather than generalizing from it in majority of the cases, which is why there is a need to address that problem. And where does it crop from? So large number of parameters is one of the issues. Another problem is because our data set also has long sequences. So these models tend to learn those long sequences and sort of recalls those sequences later during their inferencing or when you're doing the real-time evaluations and so forth. Okay, so what is it that we can do? What we have to do is we have to make sure that we have large data set that can help us address this problem and help the model generalize better. From that data set, we will have to make sure doesn't have only quantity, it also has quality, meaning that you make sure that you remove the noise, you remove any other sort of data set that impacts the model in a negative manner. So these plots here literally shows the current state of the language models, which is that you would see that as the scale of the model is increasing, their capability to memorize, or I would say capability to recall what it has seen in its training data, that is also growing, meaning that it has much larger capability to show discoverable memorizations as the capability increases and increases. And we will see that more when I show you some of the more studies that has been already done in that space. And this is literally, again, showing the correlation with respect to the large model and how the repetition in training data is hurting the model. As the repetition is growing, you would see that the model's memorization capability is also growing. And that is also scaling with the size of the model, as you would see. So this is something that's a fundamental problem with this language model. So this is one of the major issues that you will have to solve with the data set that you have in hand. Okay, so which is why there is a need for what is called deduplication. One of the major issues, which is that when you have such a large data set, like the size of terabytes or even gigabytes, for that matter, you will see that there would be a lot of repetitive data sets, Meaning, when I say repetitive examples, that means that there would be several strings or examples with segments of length, say 50 characters or more, that would be repeating various times. It has been seen that if there are such strings or segments of length 50 or more, then the model has the capability to memorize those. It would literally emit those segments given certain hints at the input. And in fact, even if you don't give it any kind of hint, if you do, for example, unprompted response generations, you would literally see it emitting some of the examples which were actually present in the training data. So that's an issue that has been observed. Now, okay, and that, yes, another problem this duplication of the data set has is that it weighs the repeated examples more in the training data, and that literally speaks volume on the model, and that would be reflected in its validation accuracies, which would really inflate, and you would sort of have a biased view towards a particular model because it would look really nice on those validation data set when the reality would be something else. So this is again one of the study done by one of the very famous paper, or maybe perhaps one of the first papers, which is from Nicholas Carlini, and he shows that from this massive text data set, C4 data set, 3% of the examples, which is roughly 10 million documents, that are repeated in the data set. And that's a huge number for the model to literally just start memorizing on. So which is why deduplication is necessary. And the way it has affected the model, meaning the deduplication, is not only by reducing the data, which will help in sort of reducing the number of examples and using less number of training steps, but also it helps in reducing the perplexity, which is the amount of noise that the model will be exposed to. So it will have more confidence in the data that it sees, and much higher chances of generalizing to the data rather than memorizing. Okay, so what are the ways we can deduplicate our data? There are, generally speaking, two major methods that are used. One is exact substring match, which, as you can imagine, it is a very simple, straightforward approach where, for example, if you have, say, two code snippets, one looks like this, where you have two functions, one add, one multiply, and another code snippet where there is just a multiply function, right? So in the first snippet and second snippet, you would see that the multiply function is exactly the same. So if you would apply an exact substring match on this, what would happen is there would be a segment of length, say this much, which is the length of the multiply function, that would match exactly with this multiply function from the another snippet. And then we would call that or flag that particular segment as duplicated or repeated, right? So and the general, based on some empirical analysis, as I mentioned, the length that people use to get this string matching is roughly 50 or more, which has shown to have worked in the general some of the largest public data sets that are available. But you can imagine some of the challenges that this exact substring match will have, right? So if you have, say, very high overlaps in the two example data sets, but if there is a slight variation in between, for example, even here, if you consider this, if there was a case that instead of A and B, it was A and C, right? Even in that case, you would say that this multiply function is still a repetition of this multiply, right? Because just by changing a variable name, you can't say that that's not a repetition. So those sort of overlaps will not be captured by exact substring match, right? So which is why there is something called approximate matching or near deduplicate algorithms, and this is also called fuzzy deduplications. And what happens here is you would look at matching the set. You would consider the two examples as sets and apply a overlap on top of it to get a coefficient or some way of measuring the score. And if it is higher, then you would flag it as duplicates of each other. So what can be used here is a lot of similarity-based algorithm. So generally, Jaccard similarity coefficient is used to find out the overlap between the two sets. And to reinforce this, further, you can apply any edit-based similarity matching on top of it, because it is possible that the Jaccard may not always give you the exact overlap all the time. So you want to make sure that you apply some further filtering on top of it. So you can also apply some edit-based scoring on top of it. And from the Jaccard coefficient, you can just get a probability of how two documents are related or overlap of one another. And this is just an example showing how the Jaccard similarity-based approximate matching can be applied using hashing. So if you take an example, for example, here we have 3 examples, right? And if you see the 0 and the 1 example, they have some sort of repetitions with respect to the chunks or the segments of strings that you see here. So the way this method is applied is you would chunk them into shingles or say n grams, and then apply some hashing on top of it. Now to get an exact signature for each of these segments, you would go ahead and apply a permutation of those hashes or apply k different hash functions to get a good signature for each of these shingles, right? Now, once you have the hashes applied on top, you can then bucketize those, meaning that you will split them into buckets. And in each bucket, you will have, for each of their signatures, let's say we put B hashes of each of these documents. So that way, what would happen is you would be able to, if there is an overlap between some of the segments between these 2 examples, there will be it is quite likely that there will be an overlap in the hashes in more than 1 buckets. And that is what you will have to look for, and that gives you a indication that those examples are an overlap of each other. So this is another way of measuring how the examples are sort of overlapping with each other. Okay, so we talked about duplications. Next, we will cover what is called another big challenge with respect to the data sets that we are using in the language model world. And it is becoming even more and more concerning now. Why? Because we have more data sets, more test sets, which are called benchmarks. So what happens is, if you have your benchmark and your training data sets, all of them available in the public domain, there is a tendency that they will sort of contaminate or get into one another's, right? So if you have a training corpus where your benchmark has been somehow mixed, it is very, very much possible, right? Because you would see that benchmarks such as human eval, benchmarks for code, benchmark for assessing the data science capabilities, and many other tasks, all of those are available on the GitHub. So it is possible that at some point in stage, if someone comes up with a training data set and they have literally taken a scrape of everything that is available on the internet, they would not have cared what is benchmark and what is not a benchmark. They would just mix it all and it would all appear in your training data set now. So what does that lead to? That leads to contamination of the data set. Again, similar problem. So you will see a huge, a very high score in its validations with respect to the models because you forgot to decontaminate your training data. And now your model has not only learned the training data set, but it also has seen examples similar to what appears in your benchmark already. So it's going to be very good at the scores when you are evaluating it on those benchmarks, right? So that's another major problem. And the studies already shows that some of the very, very popular benchmarks that already exist and used very thoroughly, which are called human eval benchmark, these are used to test the model's capability at Python examples, right? So, and it has been shown that some of the popular training data sets, which are the pile and the stack, they are already contaminated with this benchmark, meaning that they already have about 20 to 25% of their data. They already have sort of almost 80 to 85% of the benchmark data, which is visible when you are evaluating it, and they have shown this is only increasing and increasing and increasing. Yeah, so this has been already shown in the study. So what has been done to address this? There has been a lot of work in this field again, and some of the major methods that are used are very naive approach. You take a surface level matching, which is very similar to what we did in the duplication methods, right? So all you want to do is match whether a particular example that you have, which is a part of the benchmark, does it match with any examples that is there in the training data set or not. So you can again apply some sort of a edit-based similarity score on top and see if it has score higher than certain threshold, then you can say, yes, that example is present. But again, here there is a catch. If you have a code snippet, then surface level similarity may not work because methods such as Lavenstein, edit distance-based scoring, they will not take care of specific things. For example, when there is variable mismatch or there is function name mismatch, but that does not mean they're not contaminated. Just because you were able to change the name or the variable name, that does not mean they're not the same or the repetition. So you will have to apply something different, something smarter on top, which is that try and take an AST representation of the input that you have, which can be a code or a syntactical representation of something, and then apply an n-gram overlap on top of it, and then take some sort of edit-based similarity score on top. That will then now take care of what the Lavenstein or the simple surface level method could not take care of, right? So this example here is literally just showing one of the examples. This is an example present in the human eval benchmark, and it was shown to be present in the training data set of one of the very popular publicly available training data set, which is called the stack. And the surface level method was able to catch this with a score of 79, because as I said, some of the subtle things that are present in the code snippets that are not captured by the Lavenstein score. So if you apply a semantic level similarity on top, you will get a 99% match. So this is, so people have also used these two in combination at places where they have compute compromise to take care of, because not always can you do semantic level. It requires more level of computations. So places you have higher confidence with surface level, you would skip those and apply semantic level. Or people also play around with both of these together to look at which one has the maximum score. Okay, so let's now quickly go to some of the code quality that I'll talk about, filters that we have come up with based on a thorough empirical analysis of the data sets that we had. So once you have selected a programming language and you would have filtered any malware type of examples, for example, executables and all of those which can have vulnerabilities, and model is definitely not going to learn from anything good from those kind of examples. You want to get rid of those. There are lots of tools already existing in the public domain which you can use to filter the malware. So there is no need to come up with an algorithm from scratch for those methods. And there are certain other type of artifacts in the code snippets that you want to make sure that you remove those. For example, there are alphanumeric filters that needs to be applied, because there are certain examples, as you would see here, which would have a lot of special characters and symbols, as well as spaces and tabs, and not a lot of logic. There would be literally 2 or 3 lines of logic, and the entire code snippet would be filled with these random characters, which the model is not going to learn anything from. So you can filter these things out, and based on our analysis, we found the perfect score that worked for us, particularly for Python language, was this score that helped get rid of these kind of examples. Okay, next kind of filter that you can think of is removing code snippets that have auto-generated terminologies appearing in the header or as comment in between the lines. Why is it important to remove these? Because when you have these words like auto-generated or auto-generated, automatically generated, and blah, blah, similar kind of words appearing in the code snippet, that means this code is not generated or written by a human. And you want the model at first to learn the syntax or semantics from the human perspective, what human thinks, how a logic should be written. Safer to remove these kind of code snippets because you may not know if it is correct, if it is not correct, if it is generated by already a language model. You need a further level of verification to check if it was correct or not. So you want to be safe, remove these kind of code snippets. In addition, you want to also remove any code snippets where you have encoded data. You will see snippets where you have inline code where you will have hexadecimal string or as assignment to variable and so forth. Unless there is a literal mapping with respect to those encodings, we have observed that model doesn't learn much from these kind of encodings. Best to remove such sort of code snippets where these characters appear as well. And then there are certain other types of files that you would have in your repository, such as text files, which are really, really long. They will have large number of lines, including very, very large number of characters. But they are literally like documentations or maybe licenses or filter or those kind of documentations, which is not helping your model a lot with respect to learning the logics. So you also, as well, might want to remove those kinds of files. Next, you want to also take care of what is the average line length in your code snippet. If you have very long lines that are there in the code snippet, it hampers the model's capability to learn from those. Why? Because it is possible that the model that you're using, it does not have the capability to look at longer sequences and be able to learn from those at a point in time because it is not very long context in nature. It has a shorter window. So you want to make sure that the lines that are present in your code snippets, they are within a certain boundaries which the model is capable of learning from. And these are the analysis that we did and found that for Python, these were the roughly average number of line length that works for Python, and it sort of varies for various programming language, as you would imagine, because other programming languages such as C or C++ will have boilerplate code because they do not have lots and lots of libraries or wrappers. So, and in those cases, we found that various examples will have these kinds of content, which is again not very useful here because this is just a variable initialization with respect to memory addresses and I don't know what not. And model will not learn a lot from here. So you might as well remove such kind of code snippets, which helps in reducing the noisy kinds of code snippets further and further. Okay. Next, we have what is called characters to token ratio, where you are measuring the number of characters to the number of tokens for that same string that would be generated. And what is the ratio with respect to that? So the reason I say that is if you look at the number of tokens with respect to a particular string, that may be different as opposed to the number of characters. Why? Because I'm not going into the tokenization here, but when you're doing the tokenization, as you can think, you're fragmenting the words further into smaller units. So those numbers that you have with respect to the tokens, that will be different from characters. And you want to have a balance with respect to those as well. So that helps in avoiding a lot of noisy kind of code snippets, where if you have a lower ratio, meaning that would mean that your code is really, really truncated or obfuscated, and it is not really adding a lot of value. So you want to get rid of those. But if the ratio is really high, that means the code snippet has really unbalanced amount of comments or non-English text and so forth. So you want to, again, get rid of those kind of examples here. And the ratio that we found that worked for Python-specific language came out to be 0.5 to 1.1 was the ratio that worked for us. Now, let me talk about the last filter that I want to talk about, which is semantic ordering of the code files. What do you understand with this type that I say here? So what does this mean is, literally when you're preparing your training data, you would make sure that your data is completely randomized. right? That's one of the first and fundamental things that you do. But when you do that, what are you also missing here with respect to code snippets? When you're looking at code, think about a GitHub repository. In a GitHub repository, it may be a project file, right? Where you will have multiple Python files. They are all talking to each other. So they are sort of, in a way, having a relationship, which we lose if we go and prepare our training data where we are literally just randomizing the examples. So we have lost that inherent and natural structure that the repository literally had. So if we provide that order or structure to the model when it is training, it is helping it get the context that would be really required for one file with respect to other. Meaning, all the files that are related to one another, we need to make sure that they are in proximity with one another when the model is learning. And they're not literally just interspersed with the other repositories files. So that's the whole idea. And what we did here is we came up with this method that, so yeah, this example is literally just showing that, for example, you have two files, file A and file B. Here, this particular file is called from this file A. So for example, this process function is imported from this file A, and the training, the model that is training on this data, it needs to know. Otherwise, the context about the process in this file will be lost because it will never know what really the process was. So we have to make sure when the model is training on this particular file is in the proximity, so that before the language model's memory goes on to or shifts its focus to the other parts of or attention to other parts of the model, it has somehow learned this context in vicinity with one another. So to do that, what we have done is we make sure that when preparing our data, we prepare a dependency graph with respect to the repositories. And what we did is we sort of removed the cycles and all to get a directed acyclic graph, and then formed a topological sort on top of those DAGs. And on top of that, we added any of the readmes and documentations that would be available. Now, taking these topologically sorted files that we would have, we would pack them together and then show that to the model rather than showing them interspersed with the other examples. So that's what I meant when I said that they need to be in proximity with one another. And when we trained our model based on this type of ordering, what we observed is that there was a significant boost in the model's performance on especially tasks that required long context. Because you can imagine, right? If in a repository you have multiple files that are talking to one another, when you are prompting the model on certain kind of examples where you're providing not just the question, you're also providing, say, some Python function, right, as a way to give it to generate more on top of it. So you are giving a long context as an input. So we saw that in those cases, the model had a significant boost. And that was our study that we did. And this, yeah, so with that, I would like to come to our summary, which is that, see, high quality data is really non-negotiable for all of us. So we really, really need to prepare our data in a manner that is really high quality, because what we give to the model is what it learns. And that's what we have observed everywhere, right? You give it bias, it learns all of those biases. You give it duplicates, it learns to repeat. So all of those comes from the quality of the data that we show it. And then data preparation is complex and time consuming. As I mentioned, there are various stages to it. We need to make sure that somehow we have a pipeline or we have a framework that puts all of those together for us so that they're all taken care of and we do not miss one or the other when we are doing our processing. And third, we have various downstream applications with respect to different modalities of the data. So we also then need to make sure that our pipeline works for all of those modalities and not just for, say, text or for code or vice versa, or images. Yeah, and then we have to, yeah, and then all of these scale with the data size. So that's the inevitable issue that we all have. So which is why, as I said, and I'm again repeating, that we have come up with this toolkit, which is called Data Prep Kit. Please do go and check it out. It's really cool, very, very simple to use. And you can also look into the code snippets, all of the transformations or all of the data recipes that we have. If you think that any of the recipes has scope for something interesting that you have come up with, do raise an issue, or yeah, so that's how you can also contribute to this toolkit. Now, going ahead, I talked about, so I'll talk about some of the interesting problems that we can work on going further, which is that we talked about all of the high quality data. Now, can you imagine if I am talking about here terabytes of data, how much of that terabytes of data are we really retaining for training the model, like generally in the community? Any guesses? I mean, I know it's on the slide, but yeah, we are literally discarding 95% of the data. Can you imagine, from those terabytes of data, we are discarding the 95% of the data? So just like we do think that just like we learn from what not to do, there is a scope that our models should also learn from these what not to do or the trashed data. And that's what we are interested in doing here. And don't pay attention too much to this. This was just generated by a language model. I just asked it to literally translate the trashing of the 90 to 95% data, and this is what it did. So yeah, but anyway, from this, what we think is there are various questions, research questions that we can target, which is that, can we train a model that automatically assess what is good and what is bad? Just like we know that if we see a code snippet, we know what is good and what is bad. But so far, our model has only seen very, very high quality data. We want it to expose it also to what is bad. And can it then help us do these kind of filtering on its own? Does it get smarter at knowing what is bad? And can it then help improve its own capabilities? For example, can it unlearn the bad coding practices on its own, because now it knows consciously what is bad quality data? And then can we also use it to do various other kind of things, right? There would be dead code, there would be scope for refactoring the code, because at first it may not generate the most optimized code. And generating most optimal code is very, very essential in various domains, for example, in the hardware domain, right? So if you are training your language model on a hardware-specific programming language, such as Verilog, you need to make sure that your generated code snippet is optimal. So can it do its refactoring on its own? So these are some of the research questions that if you are interested, we are happy to talk about it. I don't have a lot of time, but I do want to take you through something which is a demo notebook. So if I cannot run all of this, I will just show you through all the stages. Very easy to learn. All of the data recipes that I talked about, they are all, you can play around with all of those with a demo data set, all of which is present in this notebook. So I will try to open it in the Colab so we can easily run it. So as you can see, all of those stages that I talked about, they are all mentioned here. Oh, sorry. Yeah, I'll take 2 minutes. I'll take 2 minutes and then we can shut down. Sorry. Yeah, so I'm just going to show you all of the data recipes that we talked about. They are very crisply and in a very simplified manner put all together in this notebook. Very easy to run. You can just open it in your Colab and run these stages. It runs for a sample example file, which is Earth PDF and Mars.pdf. You just have to download those here and then go about running all of the data recipes here. So this is just the first one, which is converting the PDF to one of the data format, which is Parquet file, followed by, this is just the format in which your data is now present. So you can look at it. How does it look? And then, yeah, so this is where you are now chunking it. As I mentioned, any PDF you take, it will be really, really long. You would need to chunk it into smaller snippets, which is what is happening here now, followed by, so these are all the steps, very, very easy to run. Here we are associating an ID to each of those chunks now, so that it becomes easier for us to do any kind of processing on top, and we remember what kind of processing we did. This is the exact substring deduplication that I talked about. Again, very easy to execute. This is one of the launcher that does the exact dedupe method application. Yeah, and then that's all we are talking about. Fuzzy dedupe is in one of the other notebooks that was also mentioned in the slide. And this text encoding is literally just doing the tokenization in the end, or the vectorization. So take a look. I am around. If you have any issues, happy to take any questions.
Any questions? Maybe you can take one or two questions.
Hi. So I just had a small doubt. You might have covered this, but given a generative AI, how do you, given an output, how do you detect whether it's generalized or memorized? So I imagine if you give an input that is similar to what it's learned, it should give an output that is similar, right?
Right, so that's a good question, and it's hard to identify in the general space whether what it is emitting, is it generalized or memorized, because you would not know unless you have access to its training snippets or you're familiar with what it was really trained on, right? For example, if I have written some book and it was on the internet, and somehow I see these language models literally emitting a phrase from my book as is, then I can go and claim, hey, your model has actually memorized. Otherwise, it is just hard. Who knows what was there in the data set? Unless you use some sort of a method such as watermarking, which some of these companies are going ahead and starting to use in a way to protect the licensing or all of these. So yeah, that's I think how I would put it.
So just one more thing, I noticed in your slides you had given credit to image that was generated by AI. So is there any current intellectual property rules on that? Content that is generated by AI?
Are you asking that to me or in general? Is that a question?
No, in general, in general.
I think it would be best to follow our good practices that we should generally do, right? Like we should give credit to someone whose content we are using. Yeah. All those regulatory authorities, bodies, coming up with such kind of rule books, best practices, and also bringing that to a legal paradigm. And EU guys are much more concerned about this part. I mean, recent countries such as ours, India, but the European world, they are much more conservative. So these things are evolving with time. You also need some bit of a technology development. That's what I call out, like transparency, compliance, governance. These are all different topics.
Thank you.
So my question is, like, there might be other models as well, right? So what makes this data prep kit best compared to other models as well?
Are you talking about models or data?
Just the models. Like how, compared to other models, what is the most featured thing in the data prep kit? What makes this much better compared to others?
Are you asking about other data preparation uh, tools that exist? And do we have to compare with that? Because model and data prep kit would be different, right?
Like the model only.
So why is the data preparation important?
Yes, yes, yes.
Okay. So the reason why it is important is, as we all just talked about, there are various issues that you face. By the time you would have already trained your model, you will not have the capacity to fix it. So for example, let's say your model now shows that it has actually learned to emit licensed code snippets, right? And it doesn't give credit. Someone can come and sue you. So one of the major problems. Second, if it is learning repeated examples, it is memorizing. So yeah, again, that also results into emitting what it is learning and not doing good. In terms of code quality, if you are not showing it really, really high quality code, think about it like, for example, when you are also writing code, right? If you would write a code, you would make sure that it is optimized so that the rest of the things that works on it is making sure that it is optimal, not taking a lot of time, blah, blah. Second thing, you make sure that your code is following consistent style. It is not buggy, one of the major issues. When you are asking a model to generate a code, you would want to make sure that it is correct. Correctness can have various dimensions, but to begin with, the basic dimension you would want to have is that it is not syntactically incorrect, right? If you compile it, it is compiling, and if you test it again, your test cases, it is executing well, or that it is adhering to the objectives that you wanted to set it to. How do you make sure that all of these are taken care of? You would want to make sure that at least the data that you are starting with, it doesn't have buggy code, it doesn't have malwares, it doesn't have cases where you had lots of examples where there were only licenses or documentations and just 1 or 2 lines code snippets. What would the model really learn from those kind of examples? Not much. You want to make sure that you remove the noise as much as possible so that the chances for the model to be good at all of these challenges that I mentioned goes high, right? Because it's, see, as all of us talked about, even going through these stages, training, data preparation, it's not easy. It's very compute intensive task. You want to also make sure that these cycles, it doesn't repeat. So especially when you are doing this task at scale, like terabytes, imagine the amount of compute and time and expertise that would be needed. So yeah, I hope I answered the questions.
We'll take one quick last question.
Hi. So as researchers, we normally go through a lot of research papers. In fact, our professor suggests us to go through one paper every day. So for research papers, how can we how can we adapt the data preparation kit so that the model can essentially learn the concepts that's been discussed over there? Because research papers, they deal with different concepts. So you have new research papers coming up with new technologies. So how can you essentially adapt this?
Yeah, good question. And an evolving area, I guess. It's going to be never ending, as we all know, as Pratibha is also laughing.
Yeah, I think best thing is first to replicate what is there, right? And this serves as a baseline toolkit. When you start playing around with data, you may discover some new gaps. And then you can orient your research problems to address those gaps. Typically, that is the process by which you carry out research, right? I mean, you don't all of a sudden discover the problem. When you take the baseline and then you start playing around with it, then you understand where the problems and gaps are with respect to whatever is existing as a prior art. And then you improvise and bring more methodologies on the table. So it's a small. Okay, one more thing. So I think thanks to Shailaja, she covered so well all of this. So one question you can ask to Google, how much money was spent to create ChatGPT model? And whatever she has discussed here, if we don't do that, we end up wasting maybe second digit order, millions of dollars. So this is a very, very important step, guys, right? Thank you. Yeah.
Iteration is not possible.
Thank you, Shelja. So one announcement for the online audience. We'll take a break. We'll be back in 15 minutes. So please stay online. For the in-person audience, we have one request. We want to take a group picture with all the attendees and the speakers in front of the EC department main building where you registered. So, and after that, we'll take a tea break. And so we are running behind schedule, so we'll have to cut short that tea break. So please be back quickly. But before that, let's take a quick picture and then we'll let you discuss over the tea.